All right, guys. So the last section, if you have your blue paper out, we're going to finish the last two formulas on there. It's all about future value. Honestly, I really like these formulas because these formulas are kind of like asking the question like, hey, I want to buy a car. 5 years from now, I hope to buy a car that's going to cost me $20,000. How much do I have to put in like now so that it's worth that much in that amount of time? Or how much do I need to put in every month? Like how often do I have to save it in order to get that amount? No, no variables. The formulas are reworked so that all you have to do is plug the numbers in and you're good to go. So they were already reworked for the right stuff. Good. See, it's very real world, right? There you go. So now you'll be able to figure that out. All right. So guys, for today, the goal is to calculate the present value of a single deposit investment. If it's a single deposit, what's that mean? Once. I'm taking one amount of money, I'm putting it in the account one time, and I'm just going to let it grow with interest. Okay, and then the present value of a periodic deposit is like every month I'm going to put so much money in here. So like how much will I have to put in every month to get 100 grand in 10 years, whatever you're trying to figure out. I'd like 100 grand, but I don't. Anyway, I went ahead, it looks like a lot on your paper, but I didn't want to waste time you guys writing all of this, so we could just kind of talk through it, be a little easier. So present value, what that means, because that term gets used quite often, it's just the current value of a deposit that's made in the present time. So in other words, it's talking about like if I want to save $20,000, in 5 years, how much do I have to invest now, either every month or a lump sum to put in to have that amount? Okay, that's what we're talking about. So what does it mean to calculate the present value of a single deposit investment? To me, it makes the most sense to look at the example. How much should I deposit into an account now so that I have $10,000 in 20 years? So I'm making one deposit to see how much I have to put in to make it grow with interest only. And then the periodic deposit investment is talking about how much money do I have to put in monthly in order to have $7,500 in 4 years. Yeah. So there you go. So I think very real world. Like Abby just said, she needs to save for a vacation. How much does she need to save every month to get the amount she needs? And if you're putting it into a savings account that gets interest, you want to take that into account because that's going to help get you some more money. Noah? A lot, because you have tax, you have titles, you have fees. It depends where you buy it from. There's a lot goes into that. That's not just a straight answer. Sorry. All right. So here is your formula for the present value of a single deposit. So I'm depositing money once and letting interest grow on it. Okay? So it should look familiar. All these formulas look very similar. So it's going to be half the issue is going to be just how do I know which formula to use when? So I think Thursday in here, our main focus is going to be here's a whole bunch of problems. You just tell me what formula I use with it. Not even necessarily solving them on Thursday. Our focus, can we get a what? Sure. So, but you know what I mean? Like that's going to be probably our focus, I think, for Thursday. Just here's all these problems. What formula do I use? You have 6 formulas. You have to know which one goes with what just by reading it. So that's usually half the problem with this chapter. No. All right. So, but notice it's reset. This formula, it looks similar to your other ones because what's happened is they took one of your other formulas and they reworked it, solving it for P in order to get where I can just plug numbers in and get an answer. I don't know about you guys, but that makes my life a lot easier. So this, the P stands for your principal or original balance or the present value. In other words, how much money do you want? You want $7,500? You know what I mean? So how much do I have to plug in here? So the balance would be your 75. How much do I have to put in every month in order to figure that out? That's like what you're solving for. So your balance is how much money you're trying to get. 1 plus your rate, still has a decimal. N is still how many times it's compounded a year. And then your T is still your number of years. So if I would tell you 18 months, how many years is that? It's a year and a half, so 1.5. Okay, so you will have that kind of thrown at you a little bit, like they'll give you so many months. Divide it by 12 to figure out how many years that is. Okay. All right, so here we go. Mr. and Mrs. Johnson know that in 6 years, their daughter Ann will attend state college. She will need about $20,000 for the first year's tuition. College is expensive. All right, how much should the Johnsons deposit into an account that yields 5% interest compounded annually in order to have that amount? Round your answer to the nearest $1,000. All right, so what we're looking at, if you kind of read through here, we need 20,000. That's our goal. So how much do they have to put in? Does it say they're putting in money every month? Every week? Nothing? They're just putting it in once. So that's how we know it's the single deposit. And we know what formula it is because it's asking you how much should they put in order to have this amount. Okay, so it's not like, hey, I'm putting in $10,000, how much money will I have? It's how much do I have to keep putting in order to get that amount. So we're trying to figure out how much I have to put in one lump sum. All right, so using our formula, P, it's the part I'm solving for, I don't know. My balance, how much do I want in there? I want 20,000 divided by parenthesis 1 plus, what's my rate? Good, 0.05 divided by n. How many times is it being compounded? Once, because it says annually. That's 1. Then it'd be 1 times how much time? 6 years. This is where the calculator comes in. So grab the graphing calculator, or if you're comfortable with the other one. Let's type it in and let's see. And it'll tell us how much they need to invest a one-time lump sum in order for it to grow to that amount in 6 years. All right, so grab the calculators, guys. Some of you are just sitting there staring at the wall. Right. Well, first, tell me what the actual answer is, and then we'll talk about rounding it. There it is. I think you might have forgotten a 0. So we get $14,924.31. But the question said round your answer to the nearest $1,000. It'd be 15,000. Rounding to the nearest 1,000. So right now it's at 14,000. So you round up, it'd be at 15,000. Okay. So these questions kind of go back and forth. Like, if they don't specify what to round to, then give me the exact answer that you get in the calculator. If it says round to the nearest dollar, if it says round to the nearest hundred, round to the nearest $1,000, you have to really watch what it's asking you to round to. Questions so far on that one? Noah? Question or stretching? Okay. Xavier? Okay. Okay. All right, number 2. Jada just graduated from college. She wants $100,000 in her savings account after 10 years. How much must she deposit in that account now at a 3.8% interest rate, compounded daily, in order to meet that goal? Round up to the nearest dollar. Well, she's given herself 10 years to get that much. Maybe like the first year out of college, she might not have so much. Depends what kind of job she has. Maybe she's like a, I don't know, aerospace engineer or something. Something tells me they'll make good money. I mean, if she's a teacher, then she's going to struggle to save that much. All right. So we plugged stuff in the formula. So her balance, she wants 100,000. 1 plus her rate was 3.8%, so 0.038. How many times is it being compounded? 365. It says daily. And then 365 times how many years? 10 years. Yes. $68,387.49. We'll talk about the rounding part. We'll get there. All right, so $68,387.49. Right? It says round up to the nearest dollar. You see it? Round up to the nearest dollar. So what should you round up to? Yeah. So $68,388. Because if you round down to the 87, will she actually have the amount that she wants? No, she won't. I don't know about you, but straight out of college, I don't think I have 68 grand to throw in an account. She may want to try the next option and like put stuff in monthly to better reach her goal. Yeah, this is in 10 years. Yeah, but that's like a one-time lump sum is what she's doing. So yeah, she may want to look at the next option of maybe putting it in monthly. All right, questions on this? Notes today shouldn't take too long, but we okay here? All right, and then the next part is a periodic deposit. So instead of me just taking a single lump sum and putting it in the bank, now like every week I'm putting money in, or every month, or every quarter, or twice a year. Like I'm constantly putting money in it. Okay, not just a one-time deal and done. So that formula is like the mother of all formulas. That thing's beautiful, isn't it? You want to memorize all these formulas? I wouldn't want to. Can you imagine that if I was that mean? Like make you memorize all of them and know when to use them? That'd be awful. Well, quadratic formula is an easy one. That's a one-time thing. This is 6 formulas that all look very similar. That'd be crazy. Thank you. The annoying song that I played all the time. I'm teaching that on Friday in my Algebra 2 class. All right, guys. So same variables that we've been working with, but this one is a periodic deposit. I need to make sure we're recognizing the difference. Single deposit, I put money in once. Periodic, I'm constantly putting money in. So here we go. Example 3. Nick wants to install central air conditioning in his home in 3 years. He estimates the total cost to be $15,000. How much must he deposit monthly into an account that pays 4% interest compounded monthly in order to have enough money? Round up to the nearest $100. So again, notice that it says he's going to how much he deposit monthly. He's depositing money every month, so we know it's periodic. Okay? So we're going to go P equals, here's the fun formula. How much does he need? 15,000. The rate is 0.04 divided by, what's the N? 12. Good. So it's compounded monthly. All of that over 1 plus the rate, 0.04, divided by N, which is 12, to the N times T. So 12 times how many years? 3 years, minus 1. Holy smokes. Grab the calculator. Let's type it in. Make sure we're understanding those buttons. So what answer does your calculator actually give you? 392.86. But the directions say round up to the nearest 100. So it'd be $400. So $400 a month, if he puts that away, he's going to be able to afford his air conditioning in 3 years. Thanks, Xavier. Mm-hmm. For up here, I type the whole thing in the calculator at once. If you do it otherwise, you would take this divided by that. So 0.04 divided by 12, and then multiply that answer by 15,000. Just be careful not to lose digits off of decimals, because if you round it at all, it's wrong. Okay? All right, questions on that one? 1 to go? Think we got this? Some of you are already moving ahead of me? Overachievers. All right, Sunny needs to repay her school loan in 4 years. how much must she semi-annually deposit into an account that pays 3.9% interest, compounded semi-annually, to have $100,000 to repay the loan? I feel like Sunny is screwed as well. Good luck, Sunny. I hope she has a really good job. Yes. I have, yeah, pay it off in 4 years, that's crazy. Mine are 10-year loans. Yeah, mine are 10-year loans. That's typically if you like get like a direct loans, like student loans, typically they give you 10 years to pay them off. All right. But do we see why this is the periodic one as opposed to the single? How do we know this is the periodic formula? Yeah, how much they semi-annually depositing. So it's not just a one-time thing, I'm putting it in and letting it grow. We're putting money in semi-annually. All right, so P equals, we're looking for $100,000. The rate would be 0.039 divided by, how many times is it being compounded? 2. Semi-annual means 2. Divided by 1 plus my rate. We divided by 2. We're talking about 4 years minus 1. Holy smokes. It's a lot. Now, where do I round this to? You don't. The directions did not say anything about rounding. I want the actual answer to the nearest cent. Thinking about money here. How much must she put in there twice a year? 58 cents. So twice a year, she's got to put in over $11,000 in order to do this in 4 years. Whew. Poor Sunny. Hope she's got a good job. All right. Questions on what we just went over, the last 2 formulas? Okay. Again, individually, I don't think any of the formulas are terrible. What's going to happen, though, is when it comes time for, here's all of them, pick the right one, where we're going to struggle a little bit. Okay? So tomorrow, our goal is to go over what we learned yesterday and today. We're going to do an activity. It's the first time I've tried this activity, so hopefully it goes as planned. Yay, you guys are my guinea pigs. Thank you. So we'll do that activity tomorrow. And then Thursday, we'll focus on, here's a bunch of problems, pick the right formula. It's not even going to be solving on Thursday. It's just going to be pick the formula. And then Friday, I was thinking, those of you who know me, have had me before, I was thinking about playing a baseball game. How did you never play the baseball game? No? Where you get to throw things at the smartboard? Oh. Yeah. So I was thinking about playing the baseball game. Did you have Mrs. McCourt? It's a game that I created. Yeah. Then it must be. Probably similar. All right, but anyway, so that's the goal. Then we'll review everything. Monday, I was contemplating Monday even having kind of a dry run on the test Monday. Meaning, like, it'll be the review, but I thought about having you guys take it as if it was your test. No. But then we'll grade them in class, and then you can see how you would have done, and then we'll actually do the test on Tuesday. But that way you can kind of be like, oh man, I really kind of suck at this. Then you'll know what you need to work on, kind of thing. Okay, it's kind of my thought. So we'll give that a shot.